All right, well, let's go ahead and get started. Good afternoon, everyone. We are so pleased to welcome you to our fourth session of the 2019-2020 Learning Exchange Series. I'm Todd Ontel with the Northern Institute of Applied Climate Science and the U.S. Forest Service, and I'm sitting in for our regular host for this webinar series, Lauren Cooper, who is out this afternoon. The Forest Climate Working Group is a diverse group of forest interests, including landowners, industry, conservationists, academia, and those active with carbon markets. The group has worked together for almost 10 years to advocate for state and federal policies that work to ensure sustainable forest use and prevention of land use change. We've currently been in the process of reinvigorating our focus and activities and welcome inquiries into our work. Please reach out if you have questions or think your organization may be interested in joining. So for today's speaker, I'd like to introduce Joe Fargione, who is the Science Director for the North American region for the Nature Conservancy. Today's session will focus on natural climate solutions and some recent work exploring the magnitude of different natural climate solutions at the state level. Okay, we're very excited to begin today, but before we do, I'd like to briefly share a few details. To automatically receive registration details and information regarding upcoming webinars, please email us at forestc@msu.edu to join our mailing list. Attendees today are also qualified to receive 1 CFE credit from SAF. If you are interested in this credit, please reach out to us at that same email address, forestc@msu.edu. Our session today is being recorded and will be posted on the web along with any supplemental resources such as the presentation slides. These will go up in the next week or so. If you're registered, you'll receive an email letting you know where and when to find that. Our session today is also going to be followed up with a Q&A session. So in our Zoom interface, you'll see the word chat with a little drop-down triangle next to it. Here you can offer up questions at any point during the presentation. We'll compile these and then present questions to Joe in the Q&A session, time permitting. If you're calling in on the phone, but you can send an email, you can send your questions directly to, you guessed it, forestc @msu.edu. And in case of any questions that we don't get to, we'll work with Joe to have these addressed and put them together into a document which will be shared along with the presentation materials. Okay, so with that, Joe, will you please share your screen and begin today's presentation?
Yes. Thanks everyone for joining. Todd, can you hear me?
Yes.
Great.
Loud and clear.
All right, I would like to talk to you today about technologies that can help solve climate change. Shown here are two of my favorite, solar panels and electric cars. But imagine with me, if you will, a cost-effective technology that could take carbon out of the atmosphere and turn it into a diversity of useful products. And of course, we have that, it's the plant cell. And I may be preaching to the choir here on the Forest Carbon Working Group, but as I'm talking to giving public talks, I always like to remind people that plants are made of carbon. In fact, life on Earth, as you may recall from your high school biology class or Star Trek, are carbon-based. So plants are about 50% carbon. And what many people don't know is that there's almost 4 times more carbon in soils than there is in the atmosphere. And I know we're talking specifically about forests and trees today, and that is where most of the plant biomass is, but I do have to give a shout out to grasslands, where roughly 80% of the biomass is below ground. that there is a fair amount of carbon in grasslands as well, both in that below ground biomass and in the soil. And the way we've defined natural climate solutions to include both natural and working lands, we also talk about methane and nitrous oxide, which are potent greenhouse gases. So we know that that nature is made up of carbon, and there's an estimate that there's roughly 2.5 trillion fewer trees now than there was pre-human civilization. So getting some of that back through reforestation, protecting what's there, rebuilding the soils in our agricultural and working lands, how much can that really add up to helping solve the climate change crisis? And so what I'd like to talk to you today, the rest of the presentation will be trying to answer this question globally and in the United States, and then diving in to talk a little bit about some specific opportunities with regards to forests and trees in the US. So starting with how much can nature contribute globally, there was this paper in the Proceedings of National Academy of Sciences in 2017, led by Bronson Griscom and myself and a bunch of colleagues. And it defined natural climate solutions to look at 3 types of action: so protection, restoration, and improved management. And we looked at these categories across 4 different biomes of forests, grasslands, wetlands, and agriculture. And we imposed some constraints. So we said we could reforest all of the world's cropland, but then we wouldn't have food to eat. So that's probably not a very useful scenario. So what can we do given the constraints of meeting demands for food and fiber? And then I work for the Nature Conservancy, which is a biodiversity conservation organization. So of course we had a no harm to biodiversity constraint. And the biggest place where that comes into play is we were careful not to propose reforesting grasslands, because as much as we all love forests, there are lots of critters and some people that are pretty attached to grasslands. So we don't want to reforest grasslands, even if it's climatically possible. And so just cutting right to the chase, if you fall asleep for the rest of the talk, the kind of headline number is that there's 24 billion tons per year maximum potential from natural climate solutions. And this was looking across forest, grasslands, and ag lands and wetlands. And you can see that the bulk of that is in forests, and in particular reforestation and avoided forest conversion globally are really big opportunities. Natural forest management is also a big opportunity, and they're also much more uncertain as to what the potential is there, because it depends so much on sort of what current practices are for management, et cetera. And so this is helpful as a sort of upper bound, a maximum potential. But a common question is, well, how much of this could we achieve? Especially, how much is feasible? And one way to think about that is at different price points. So there's this concept of marginal abatement costs, which is if there were a price on carbon, say at $10 a ton or $50 a ton or $100 a ton, how much would that incentivize at each price point? How much mitigation would you get? So obviously things that are relatively inexpensive, if you pay $10 a ton, then you get all of those. But things that are more expensive, you might require a higher price. And this could be, we don't specify the mechanism. So it's a price. So if you had a cap and trade system or other mechanism that was paying for this, that's a price. If you're a landowner and you're reforesting, that's revenue, right? Because you're being paid for that benefit you're providing. So estimating the marginal abatement costs of these different practices, we find that much of the potential is available at relatively affordable prices. So, so at $100 per ton, would get 11 billion ton potential, and this is annual potential. $10 per ton, you get 4 billion tons of carbon dioxide per year, kept out of the atmosphere of both avoided emissions and increased sequestration. And so one of the things I always like to point out is that natural climate solutions have many co-benefits. And so that previous slide looking at cost is assuming you're just paying for the carbon, but it's really important to point out that if you were to do that, you would have significant additional benefits with regards to air quality, soil health and fertility, biodiversity habitat, and water, both providing clean drinking water and helping to regulate floods and store floodwaters. And so at $10 per ton, you would get those 4 billion, you would get those 4 billion tons of carbon dioxide per year, but you would also get many other benefits. And this is important because that price may be misleading. There are things that are expensive if you only consider the carbon, but that society regularly invests in. And that's typically because of these co-benefits. So urban forestry, for example, when you look across natural climate solutions, is relatively expensive. But when you look at the kinds of things that people are willing to pay for, urban forestry often rises up there as one of the things people are willing to pay for because it's a quality of life benefit. They're not paying for the carbon per se, they're paying for those co-benefits. So to emphasize that natural climate solutions have strong co-benefits, we weren't able to quantify the magnitude of the benefit that you would get for each of these things, because which would be really challenging. But we did identify kind of present absence of whether a particular natural climate solution contributes to co-benefits with regards to air, biodiversity, soil, and water. And the take-home message here is that most of the natural climate solutions provide most of those co-benefits. So we talked about billions of tons, and that sounds good, but put that in context. What does that mean? Is that significant? Would it help actually solve the climate crisis and meet the ambitious climate targets that have been set? And so one way to look at this is the business as usual trajectory of emissions going up is shown as a black line. And you can see the slide's a little old since we're now in 2020, but I think the point remains. And the green line shows what a pathway for keeping the temperature warming less than 2 degrees Celsius. And so that gap between the black line and the green line shows the amount of mitigation that would be required. And what we see is that natural climate solutions, if it's scaled up to its maximum potential at $100 per ton marginal abatement cost, that's scaled up by 2025 to that potential, it would give a mitigation equivalent to the green line shown here. And then in order to stay on that less than 2 degrees warming, you would need an additional mitigation as shown here in the gray. And so when you put it all together, the natural climate solutions could contribute 37% of the solution needed between now and 2030. So roughly a third of that solution, in the next decade. So one of the reasons that we think natural climate solutions are so promising and essential is because they're available now, and when we're communicating about these to the public, it's very important to emphasize that this is not an instead of solution, like, oh, we can do natural climate solutions and not worry about rapidly transitioning our energy systems away from fossil fuels. In fact, we need both. And the latest science shows that simply rapid transitioning our energy systems off of fossil fuels will likely not be adequate to meet the ambitious climate targets of the Paris Agreement. And in fact, we will need carbon dioxide removal technologies. And while people are working to develop other carbon dioxide removal technologies, right now, the most cost-effective of those are natural climate solutions. So to summarize the global results, at that $100 per ton of CO2 price point, there'd be 11 billion tons of carbon dioxide per year of mitigation. And that's roughly a third of the mitigation that we would need between now and 2030. And it's roughly equivalent to stopping all emissions from oil. That's about a third of our emissions. So I think to the answer of, to the question of, is this potentially significant? Is it worth talking about as a reason to invest more in protecting nature, restoring forests? I think it is. I think it is potentially significant. I think it's likely necessary to help us meet our climate targets. And we always need to emphasize in our communication that this is additional to the change that we need to see in the energy sector and in our residential home heating and other and concrete. It's in addition to all those other things that we need to do. But I don't think it's distracting. I think it's essential because we're going to need this additional carbon dioxide removal. So that was great to have kind of a high level global perspective and understanding that this is potentially globally significant. But of course, that global action is difficult, and the action takes place, in nations and states. And so a better understanding of what the potential for natural climate solutions is at the state level seemed at the country level and the state level seemed really important. So one of our next steps was to do this work and publish this paper on natural climate solutions for the United States. And jumping right into the results, we found a maximum potential of 1.2 billion tons carbon dioxide per year. And again, the bulk of that comes from forests. And so we looked at reforestation, natural forest management, avoided forest conversion, urban reforestation, fire management, and some improved plantations, extended rotations and plantations. And again, these different price points. So we looked at $10, $50, $100 per ton of carbon. You get the majority of that mitigation potential, a 90% at the $100 price point. And 75% of it, 0.9 billion tons at $50 per ton. And 300 million tons at just $10 per ton. So we picked those price points. $10 is roughly the current price on voluntary markets, and the existing regulatory markets are in that order of magnitude. So it's 300 million tons per year just in the U.S. $50 is the Obama administration's kind of median estimate for the social cost of carbon, which is highly dependent on what assumptions you make and therefore debatable, but kind of on that order of magnitude are pretty common for social cost of carbon estimates. And $100 per ton is what some economists have estimated would be necessary to keep us on track for that Paris Agreement. So that's how we came up with those numbers. But to give a sense of the potential magnitude. And again, there are really strong co-benefits of natural climate solutions across air, biodiversity, soil, and water. So 1.2 billion tons sounds like a lot. What is that in context? So from the National Carbon Inventory, the net emissions in 2016, that considers both the emissions and the current land sink. We argue that this 1.2 billion tons would be could be achieved additional to the current land sink. So it's actions that would be taken that would increase that. So that ends up being 21% of our net emissions, our most recent net emissions, and that's equivalent to the pollution from all the cars and light duty trucks in the U.S. So potentially a significant amount of mitigation for the U.S. I think this was somewhat surprising to people because, you know, when we think about globally where natural climate solutions can make a big impact, we often think about tropical countries that have high rates of deforestation and perhaps are less developed and have relatively low per capita emissions as someplace where a whole nation could offset a significant portion of its or mitigate a significant portion of its emissions through natural climate solutions. But we find that even in the US, where our per capita emissions are quite high, that investing in natural climate solutions is significant and could make a significant difference. So for a bunch of the pathways that we looked at in the natural climate solutions for the US paper, we were able to break down those estimates to the state level. And so if you go to the website natureforclimate.org, there's a drop down for tools. One of the tools is the US State Mapper. And then, I don't know if you can see my cursor, but if you can toggle between a national view and the state view. And if you click on the state button, then you can pick a state and it tells you our estimate for area and mitigation potential for any state that you click on. And then if you want to change them, you can look at the maximum or any different price point. If you click on this little lock thing, when you change one, all of these change. So you switch from max to $100, it switches to all of them. So that's a existing tool. The numbers in it are consistent with what's published in that paper, in that 2018 paper. And we've done I'll say a little bit more about these individual pathways, but we've also done some follow-up work since then that's not yet published, and I want to also share some of that with you now. So we'll talk about how much can nature contribute via forest opportunities, and this is specific to the U.S. So from the Natural Climate Solutions for the U.S. paper, the reforestation estimate was based on a GIS analysis. It identified 156 million acres that could be reforested. That was pretty inclusive. It basically said, did it used to be forest? Is it not forest now? And it's not a city or a road, then it's potentially reforestable. So that was, that casts a pretty broad net. So for example, a golf course or road right-of-ways, those would show up as places that, oftentimes those would show up as places that used to be forested that aren't currently and aren't a city or a road, so those would be included. And so obviously there was a need to refine this a little bit and understand, well, which of these places are actually, more likely to be reforested. And so we broke out using that broad analysis of places that could be reforested, that used to be forests, aren't now, aren't a city or a road. We said, well, which of those are agricultural lands with challenging soils, so marginal ag land? Which of those are urban open space, parks, roadsides that could have additional tree cover? Which are places that have burned that maybe haven't recovered that might be in need of restocking? Which are places that are frequently flooded that might be unsuitable for development or challenging for agriculture because they keep getting flooded, that could go back into forests. And similarly, if you were to just say, well, let's put a 30-meter riparian buffer everywhere, what would that get you in terms of places that used to be forests that aren't currently? And then biodiversity corridors. So we had some analyses for our conservation work that identified places that are relatively intact and important for species migration in response to climate change. And so we identified the subsets of reforestation that met each of these different criteria. And this was based on conversations with people that have been involved in reforestation projects. And one of the things that we found is often they're associated with providing, other benefits, specifically around water. So a lot of work on floodplains and places that, helping to restore that floodplain might help slow and store floodwaters and have flooding benefits or water quality benefits. Other work was associated with water funds and riparian buffers and water quality protection. So these seemed like places, based on our experience with large-scale reforestation projects, that historically have been targeted and therefore are promising for future reforestation work. And so this is just one example. But since Todd's in Michigan, we have the total reforestation number here, potential, and then you can see these different subsets, and they're not mutually exclusive, right? So the flood, the frequently flooded ones and the riparian buffers are probably a lot of the same lands, might show up in both, but we can slice and dice this to look at different subsets. And we have also broken this out by ownership using the protected area database for the US. So we will have information on which of this is on federal, state, private lands, or other or local regional governments. So you can see here on the left the reforestation opportunities that align with the places we identified as corridors for biodiversity, different land uses. So some of the places that are cultivated crops that were considered marginal based on this analysis, or pasture and hay, and floodplains. And one of the things that often when we're talking to people about reforesting, agriculture groups are rightly concerned about maintaining farmland, not taking too much land out of farmland. And so we focus on the marginal lands. But I will point out when it comes to pasture that I think silvopasture is a really underappreciated opportunity in the US, that even in our temperate systems, cattle tend to grow better with some shade. And so there can be productivity benefits from to the rancher, and there can be revenue from the tree if you plant trees that produce crops, or eventually are used in timber. So that's something that it's not a cultural common practice for ranchers in the US, but potentially it could be. And I think this increasing appreciation of the value of trees on the landscape from a carbon standpoint could help contribute, a cultural change there to think more about how we can incorporate more trees in our agricultural systems. So I wanted to show a few, ground truth kind of photos from the analysis. So here, was a pasture in Florida that was identified. So you could imagine silvopasture or a reforestation opportunity. And then the National Land Cover Data Set has a land cover that they call developed open space, which I always thought was the worst sort of oxymoronic name, category name. But you can see what it's open space kind of integrated within developed areas, and so you can see places that show up as developed open space. And so this is an interesting thing to think about, right? Like you might say, well, are they really going to reforest, this lawn in the suburbs? And, you could dismiss that out of hand, or you could say, well, do we have, maybe developers aren't appropriately incentivized for having more trees, but people seem to like trees. So why is that out of the question? I don't know the answer to that, but it's interesting to think about from a policy standpoint about whether we could have a lot more trees in some of our, instead of lawn in some places. And then here's some more, conventional things that you might think of as reforestation opportunities where there's been an abandoned field or something that is, or perhaps an old clear cut that hasn't come back the way to fully to forest. That could be a reforestation opportunity. So just some next steps on that work. There's a peer-reviewed publication in preparation. It'll have national and regional analyses with some state level information in the supplementary material. And they'll look at the area and the amount of carbon you could get, and also the costs for reforestation, and some more qualitative feasibility assessment based on some stakeholder input and the economics. And then to try to make this available to people, we plan to launch a web mapper in March that would allow people to visualize and get information about where the opportunities are in their state, and a state level toolkit that will have the shape files, so the GIS layers. I guess they're mostly all raster. So the GIS layers for people to analyze, and some tools that people could use for common analyses that we expect. So another place where there's been some additional work was on urban reforestation. So in the Natural Climate Solutions for the US paper, there was, we estimated 8 million acres of potential for increased tree cover in cities. And this was based on, a really solid analysis, but it was done on 27 cities, and then we took the average potential increase and extrapolated it to the US. So on average, I think it's probably pretty close to right, but in any particular city, it's just not that helpful because you're, applying an average from 27 other cities. So, so there's clearly need for some more work here. And so my colleague, Rob McDonald, has led an effort to do forest cover for all cities using 2-meter NAPE imagery. So it has 100 largest cities, and each city included multiple municipalities, right? So I guess it's the metropolitan areas, 100 largest metropolitan areas, and then it included, all of the municipalities within that metropolitan area. So it ends up being pretty big, basically all the cities in the US. And he did an equity analysis, and I don't want to spoil the takeaway, but it turns out that there is an equity gap in terms of tree cover. So, so that's an interesting thing to think about, that not only if we're investing in urban reforestation, it has carbon benefits, it has air quality benefits, it has benefits for reducing heat waves and the vulnerable people that may be at risk from heat waves. It reduces the energy consumption for air conditioning, and so has that additional climate benefit. But we also could be done in a way that it could reduce some disparities in between rich and poor neighborhoods, so that we're having more equity for our tree cover. And so this is also in preparation for submission for peer review. So one of the other pathways or opportunities that we looked at in the Natural Climate Solutions for the US paper was forest loss or avoided forest conversion. And this work was done in collaboration with Chris Williams at Clark University, and he has subsequently, we used a relatively crude albedo adjustment in this work, and he's subsequently conducted a much more sophisticated albedo correction. So for folks that aren't familiar with this issue, it's a biggest challenge in places where there is you have evergreen forests and snow cover, because if the forest is lost, you end up with highly reflective snow for much of the year, and that can actually be relatively cooling, obviously, to have that more reflective snow than to have a dark tree canopy. And so that can offset much of the benefit that you get from protecting those forests or from reforesting. So so that can help us target our efforts on for avoided deforestation to places where it would have the largest climate benefit. So that's also work that is soon to be submitted for publication. And then finally, one of the areas that the opportunities we looked at for the Natural Climate Solutions for the US paper was on fire management, and this was focused on the Western US. And it just looked at the area that's shown here with these different colors, so these different forest types. And it made some assumptions about if you were to do treatments like prescribed burning that prevented a high severity fire, and you look out 20 years, do you regain that carbon that was emitted in the prescribed fire by avoiding high severity fires? Because what happens in a high severity fire, what can happen is a relatively scorched earth situation where you don't have very much photosynthesis happening for a long time. And so if you can avoid that that scorched earth scenario, you maintain the capacity of the landscape to continue to sequester carbon. And that ends up having a strong net benefit, even though there may be emissions upfront associated with reducing fuel load. And so one of the, so I feel pretty good about the work that we did here, but some of those estimates for how much emissions can be reduced, I think there's a lot more work that could be done to target this to places that are at high risk of high severity fire, and to refine those estimates of the benefits of avoiding high severity fire. And that's not something that we have soon to be published. I think that's just a hope for an area for future work. I will also point out that one of the biggest opportunities is related to improved forest management. And that is not something that we currently have good estimates for at the state level. The easiest thing to measure is the benefit of extending rotations. because that's the easiest thing to quantify. And so that's a lot of the work looking at changes in forest management practices have been around extending in the forest industry. That is not the first thing that they are thinking about, because they feel like they have the economic optimum pretty well figured out for their rotations. But other things like understocking, competing vegetation, thinning from below, these may, various forms of timber stand improvement, these may help increase the growth of merchantable timber and increase the amount of carbon that's being stored on the landscape, and therefore be a win-win from a standpoint of forest management. And so those are all practices that I think there's additional work to be done to understand their relative potential benefit in different states. And so one area of interest is the FIA data identifies stands that have competing vegetation, and that could be used to help estimate the potential impact of that competing vegetation on the amount of carbon there, and therefore the potential to have treatments that move them to a more fully stocked situation and increase carbon storage. So that's so these are all areas where I think there's additional need for ongoing work to better understand our opportunities and take it down to a resolution where decision makers in different states can really take advantage of it. So with that, I hope I've left plenty of time for questions and given people a lot of food for thought.
Great, thank you, Joe. Yes, you've left a good amount of time for questions, and we've got some questions that have been rolling in. So please, attendees, please continue posting your questions into the chat box, and we will be giving Joe an opportunity to address those. Joe, I'll have you just leave your presentation up during this Q&A session in case you want to kind of toggle through things. So I'll kind of start things off just recognizing you did a great job, Joe, with addressing some of the questions that were coming in as you went through your presentation. I'm curious if you could talk a little bit about kind of what is behind those estimates of climate mitigation in terms of just in a general sense, because we sort of recognize that as climate changes, as precipitation patterns change and the temperatures warm, that the carbon cycling and carbon flux processes are also stand to be altered from those changes as well. So can you just sort of briefly talk about whether or not climate projections were sort of considered in those estimates, or if that's something that's, if that's something that's going to be maybe addressed in future work?
Yeah, that's something that may be addressed in future work. So the thinking that we had was that we were most interested in the delta between what a business as usual and what an intervention would be. And so we weren't trying to estimate, the whole US carbon inventory under each scenario. We were just interested in understanding that delta and so, I think in so many of our pathways are maybe somewhat robust, so if you plant trees, you'll get we have a reasonable degree of certainty around the growth rate we would get over the next couple decades, regardless of the the climate scenario. And I think some of the challenges are, protecting forests that if they burn wouldn't regenerate. Maybe those aren't the best places to invest, as some places are becoming so dry that establishment is unlikely. So, I think there is some refinement that could be done to better understand how climate change is likely to make, essentially undermine some of our potential investments.
Great, thank you. Let's see, I had a question queued up here, and we've got so many questions rolling in here that I lost it. Okay, here it is. So Gerard asked a question that I was sort of thinking about as well. And he asked, given the difficulty of operating carbon markets, could we rely on the water bill to increase reforestation? In other words, are city dwellers willing to pay for the hydrologic services of the forest in their watershed? And this is sort of something that was on my mind as you were showing the different marginal abatement costs and the co-benefits of just whether or not some of those other co-benefits could provide some of the help with the financial aspects of these financing these projects or these pathways.
Yeah, I think that there are, the phrase we use is there's not a silver bullet. It's probably a lot of silver BBs. And so to get some of these, I think different projects will require different funding streams, and where a water fund, where a city is willing to invest in its watershed, that's a great source. It's not everywhere that it works. It works best if there's a big enough population with a small enough watershed, so the kind of the math works. So that, so Quito in Ecuador has a big population, and it's constrained by tall mountains, and so the watershed isn't huge, whereas if the Mississippi drains 41% of the U.S. So down in Louisiana, if you're one of the 20 million people that drinks Mississippi River water, that's a pretty big watershed to try to fix. So it depends. It's going to be site specific.
Yep. Good answer. Okay, we've got a question from Jennifer asking, in your U.S. analysis of forest carbon potential, did you find much difference between deciduous or eastern and conifer, evergreen conifer or western forests?
Well, let's see. So specific to reforestation, we use the Smith et al., Smith and Birdsey, Forest Service data on their growth curves and growth rates, and those. So it's for every forest type and region has a forest type and a specific growth rate, and so so the forest types that are found on on wet soils tend to be grow faster, and so there's regional variation and variation within the region based on the forest type, but it's that we are just pulling from that Forest Service data, if that makes sense. Did I answer the question?
Yeah, I think so. That made sense to me.
And so one of the other questions was about, where can you find all the assumptions? So if you, and I didn't provide a link because the easiest way is just to Google. So if you Google natural climate solutions to the United States, the first link is to the paper. It's open source. And the supplemental material is 100 pages, but it's broken out by pathway. And so we found that we spent a lot of time breaking out the pathways so they were sort of non-overlapping and could be treated relatively independently. So that allowed us to use the best available information for each one, including with the marginal abatement costs. So when we were looking at reforestation, you could go to literature and look at the papers that estimated the cost of that, and what percentage of reforestation projects were likely to be available at different price points. Similarly, and then for avoided deforestation, similarly go to that literature and estimate that. So for avoided grassland conversion, we used Conservation Reserve Program payments as an estimate of the cost of avoided conversion, because that's a program that pays people to keep land out of production. So it was different for each pathway. We are trying to finalize a similar analysis for Canada. So we hope that will be submitted in the next couple of months.
Great. Yes, that question, Catherine just asked that question. I don't know if you saw that pop up in the chat box. So is there anything else that you can say about that, or do you want to just leave it as stay tuned? Work with Canada.
I don't know. I don't have anything else coherent to say about it, except that Nature United, which is the Nature Conservancy affiliate in Canada, helped coordinate, but we had really great engagement with the folks in provincial and federal agencies in Canada. So that I think it's going to be quite a strong approach that makes use of the some of the same tools that have been used for the Canadian inventory, and so should line up pretty well with Prime Minister Trudeau's Natural Climate Solutions $3 billion policy platform.
Mm-hmm. Great. We have one small, maybe clarifying question. Somebody asked about where the $100 per ton estimate or number that was used in the marginal abatement costs. What was the kind of the thinking behind using that number?
Oh, I mean, we just semi-arbitrarily picked 3 price points to illustrate the impact of different prices of different carbon prices. And the rationale that we used for $10, $50, and $100 is that that the $100 one is what some economists have argued would be necessary to keep warming to 2 degrees. So that's they were looking primarily at the fossil fuel sector, but that's that. So unfortunately, we don't have a consistent price signal for carbon globally at this point, and it's unclear how soon we'll get there. But I think the voluntary markets and voluntary actions and state actions are quite promising, both on the renewable portfolio standards for energy and also on natural climate solutions. So the U.S. Climate Alliance states, which there's now 24 states plus Puerto Rico, have stated that they will take action to help the U.S. meet its Paris Agreement commitments, regardless of whether the federal government ultimately withdraws from the agreement. So, I think that there's a lot of opportunity for investment, whether it be specifically with a price on carbon, or whether it be in investments in natural climate solutions, or efficiency standards, or renewable portfolio standards that increase transition to renewable energy.
Mm-hmm. Great. We've got a question from Penny about essentially about public officials being made aware of the work that you've been speaking of, and I think I know the answer to that, but I was hoping maybe you could just talk a little bit about maybe sort of how these analyses have been used with the U.S. Climate Alliance states, and maybe some of your thoughts on what some of the response from planners and decision makers at the various land management agencies has been in sort of in response to these really I think thought-provoking estimates.
Yeah, I think, let's see. So the U.S. Climate Alliance has had regional learning labs that bring together delegates from each of the state to talk about the opportunities in their state. And so we shared this information with them, and they're the states are at different places on the journey of figuring out what policies they plan to implement. But I think there's a lot of excitement because in large part because there's so many co-benefits that people see. There's political support for it, I guess. So I say there's not an anti-tree lobby, so it's often viewed as a pretty win-win to invest in forests and natural and working lands and soil health. So so that's encouraging. In Minnesota, the previous governor had a buffer rule that mandated buffers. Those are in between streams and even including ditches, agriculture ditches, and where the row crops were. So most of that's been in perennial grasses, but some of that's been reforestation. So I think there are things that can and are being done at state level, and that I hope is in part inspired by the excitement that and increased awareness that this work has generated. I don't know that they're using our GIS layers per se, but we hope to make those increasingly available.
Great. Well, I think that is a excellent place to end. As I mentioned, we probably weren't expecting to have enough time to answer all the questions, so we will compile any unanswered questions and work with Joe to get answers to those posted along with the presentation slides. So just to end things, I'd like to thank Joe very much for sharing his work with us today. I'd also like to thank the members of the Forest Climate Working Group and the Forest Climate Working Group Steering Committee for their support and guidance in our 2019-2020 webinar season. Again, the webinar recording and any supplemental materials will be posted within a few days. To be included on our mailing list and receive registration details and information regarding our upcoming webinars, please email forestc@msu.edu. I'd like to thank Joe once again for his time and information, and I hope you all have a wonderful afternoon.